Seungryong Kim. I'm an instructor for this course. I'm an assistant professor in Department of Computer Science and Engineering. I'm personally working in machine learning and computer vision field. I'm really excited about teaching this course. Okay, so let me start with my brief introduction. Okay, so I joined the Korea University in March this year. Before joining Korea University, I was a postdoctoral researcher in School of Computer and Communication Science at EPFL in Switzerland. I got a bachelor and PhD degree at Yonsei University in 2012 and 2018, respectively. Now I'm a director of the Computer Vision Lab in Yonsei University, Korea University. Our main research interests 2D and 3D computer vision and visual understanding and multimodal learning and deep representation learning, something like that. Okay, so let's start today's lecture. What is the deep learning? Actually, the title of this course is deep learning, right? So today we will start with defining the terminology of the deep learning, machine learning, or artificial intelligence. Generally, deep learning refers to the artificial neural network that are composed of the many layers. So as you can see this figure, actually this is the high level intuition of the deep learning, because the deep learning consists of the multiple neuron uh, that is similar to our human's brain. So this is the deep learning. Then how this deep learning is related to the machine learning and artificial intelligence? Okay, what I mean is, what is the relationship between deep learning, machine learning, and artificial intelligence? Even though deep learning breakthrough AI boom very recently, about 2012, early artificial intelligence still excitement in early 1950, as you can see here. So to understand the deep learning deeply, we have to understand uh, what artificial intelligence is and what machine learning is. Okay, so artificial intelligence, or just called AI, is a science like mathematics or biology. It studies the way to build the intelligence programs and the machines that can creatively solve problems, which has always been considered as a human prerogative. Then, what is the machine learning? Actually, the machine learning is a subset of the artificial intelligence. Machine learning provide the system the ability to automatically learn and improve from the experience without being explicitly programmed. So in machine learning, there are different algorithms such as the subject vector machine or the random forest or the neural network that have to solve the problem. Actually, the deep learning is the one of the algorithm in machine learning field. So what is the deep learning? Actually, deep learning is the subset of the machine learning, which was the subset of the artificial intelligence, right? So which use the neural network to analyze the different factors with the structure that is similar to the human neural system. So in this course, we'll focus on deep learning, especially fundamentals of the deep learning and its training technique. But as you can see here, to deeply understand what deep learning is, we have to build the concrete background of the machine learning first. So in this course, we will first start from the fundamentals of the machine learning and then go deep dive to the deep learning later. Okay? Okay. So we are now living in the artificial intelligence world, as you know, right? So the artificial intelligence start to change almost everything in our life. So there are some news and the graph or the figure that represent the explosive growth and impact of AI, as you can see here. Here are other figures representing the number of attendance at AI conferences, such as the CBPR, Triple AI, Neurips, or ICML, which are one of the most biggest and prominent um, conferences. And here are startup developing AI systems, and here's the enterprise application AI revenue. So these statistics definitely show that the recent AI's explosive growth and impact. Okay, so the Professor Andrew Ng, one of the prominent artificial intelligence expert, compares the AI to the electricity. He said AI is the new electricity. As you know very well, electricity has once transformed the countless industry, such as the transportation, manufacturing, healthcare, communication, and more. Similarly, AI will now bring about an equally big transformation. Then, question is, why now? Why now? So, as we discussed at the beginning, the starting of the AI was about 1950, right? But very recently, there there were three kinds of things that become basis of such explosion of AI. The first one is computation. The second one is algorithm. The third one is data. Okay, so first of all, with the recent revolutionary development of the computing hardware such as GPU, you can now process the large scale algorithm in a reasonable computation time. So as you can see here, actually 2012 was the real beginning of the um, recent deep learning. So there was the a new GPU called the GeForce GTX 518. Actually, it was the first breakthrough for deep learning hardware, right? Nowadays, uh, nowadays there are much bigger and much powerful GPU released. So we can process so many data and the large scale algorithm in a reasonable time with this kind of computation module. The second reason was the algorithm. So there were revolutionary deep learning algorithm that dramatically improved the previous best performance method, which accelerate the deep learning success. So before 2012, there of course, there was the method to solve the some problems such as the image classification. I will briefly introduce image classification later, but here was the some challenges for visual recognition. Before 2012, there was the method, but they are only based on the handicraft model, not a machine learning or deep learning technique. However, in 2012, some researcher um, uh, he was the PhD student. He developed a new method just called the AlexNet, which was the first revolutionary deep learning algorithm to make a breakthrough. After this algorithm, there was so many variants of the AlexNet or the deep convolution neural network. So nowadays, almost every method or the application or the approaches are reformulated by using the deep neural network. For example, in my field, actually the computer vision field, there is a very prominent computer vision conference just called the CVPR, Computer Vision and Pattern Recognition. There almost almost 10,000 paper every year, but no, just 1,000 papers every year. But among those papers, almost 95% are based on deep learning these days. So it proves that the deep learning makes a very big change in computer vision field. We'll discuss this soon, but training the deep learning demands large scale data, such as something like the supervised learning. So in recent year, there was such a data. For example, WordNet by the Georgie A. Miller professor, and ImageNet. Actually, ImageNet datasets were used for the competition of the image classification. They have 22,000 categories and um, what's that? 15 million images. So it is really huge data. So by using this kinds of the image data, we nowadays we can pre-train our model or our neural network and then fine-tune our model on our application. I will explain this one later. Anyway, so thanks to this kind of success, we are now living in artificial intelligence world. So deep learning can be applied to so many applications, such as virtual assistant, social media, transportation, financial services, healthcare, e-commerce, something like that. So, for example, one of the most popular application is computer vision that deal with the image data, such as the astronomy here and the face recognition or the 2D and 3D medical imaging, OCR or the self-driving car. Actually, this course will more focus on the computer vision application. However, computer vision application is not just one application. Another very interesting application is the natural language processing, just called the NLP, such as the text understanding or the text generation or the spam detection or user content understanding or medical text understanding and machine translation. Actually, the machine translation is uh, has been popularly used in the Google Translator, which might be the one of the most popularly used web page, right? So okay, so Google Translator also benefit from the deep learning. Medical image is another popular example. Recently, there are many reports or the research about the COVID-19, and some of these papers try to understand the patterns of the COVID-19 by using the machine learning or deep learning technique. Audio and the multimodal data, something like this, is another example. For example, like Naver Global, do you know? Naver Global were the Apple's Siri or Samsung's Bixby, something like that. All of those methods are based on deep learning technique. And what else? Numerical or sensor data, such as the CERN, astronomy, or the fitness tracker, or the weather forecast, or robotics, or TNET data can be can benefit from machine learning and deep learning as well. Games and simulations such as AlphaGo are also very popular example. Finally, you can do many things with the internet data using the machine translation technique. Okay, so what exactly is machine learning? What exactly is machine learning? The goal of the machine learning is to look for the mapping function between input and desirable output. So here are some examples. So here are some examples of the machine learning. For example, speech recognition, handwritten recognition, or the weather forecast, or the play video games. Let's think about the weather forecast first. If we already know and have Thursday's weather, we might want to know or expect the Saturday's weather, right? So as humans like us, we can easily expect the Saturday's weather based on our previous experience of the input Thursday and Saturday's weather output, right? Another example is the handwritten recognition. Handwritten recognition here. Um, as a human, we can easily understand or easily recognize this number from this image, right? Why? Why do we can do? Because because we we have a very we have so many experience about this input and output data pair. So we build our prior knowledge between input image and output number. So that's why we can answer the number of such an image easily, right? Similarly, similar to human machine learning research, try to develop a machine learning module that find the such a mapping function like this. Okay, so this is the objective of the machine learning. Here is the machine learning framework. So machine learning framework, actually there are so many machine learning techniques, something like the random forest, the PCA, or the SVM, or deep neural network, recurrent neural network, something like that. But most of machine learning or deep learning framework can be formulate something like this one. Okay, so generally the this framework consists of the two page, training page and testing page. So in training page, given the training data consisting of the function of input x and y, output y, mm, we can find out or we can pick the best function f among the hypothesis function set or the model set. So this is the training procedure, and in testing procedure, we have to find out the label of the given input data x without using any output data y. Output data y. So this is the testing procedure. So in this course, we will try to study almost everything within this framework, especially within the deep learning framework. Okay. Okay. So in addition, later this course will cover the computer vision, one of the most interesting and important application, which benefit from recent advance of the deep learning. Then, what is the computer vision? What is the computer vision? Actually, computer vision is science and technology of the machine that see and understand as a human being does. You can see here. So, as a human like us, we can easily understand this figure, this image, where we can localize the car here, or the pedestrian here, or the traffic sign here, where we can easily understand where is the 3D structure within these images, or the semantic label from here, or the interaction between the object, object. But how can we make the machine that that predict such understanding like us? So here's the example. So when you see this figure, we can easily say that it is the Eiffel Tower, right? Because we have experience on this Eiffel Tower, right? But how does computer look? How does computer look? Actually, for computer, it is just a RGB digital information. So the question is how to make a computer recognize that this is Eiffel Tower. This is the main goal of the computer vision. Okay. Okay. So computer vision is closely related to the many other disciplines such as engineering, mathematics. Where's that? Mathematics here, and computer science and psychology, or the biology, or the physics. So that's why most of you are from the different discipline, right? So by the way, half of you are from the computer science department, but half of you are from the other departments, such as the what's that? Such as the electrical engineering department, or the mathematics department, something like that. So that's why you are here, because the deep learning or the computer vision are closely related to other disciplines. Okay, so for example, with computer vision, we can solve the 3D construction problem where where machine reconstruct the real 3D space from the partially projected image, as you can see here. By using the 3D reconstruction algorithm, we can reconstruct the real 3D world because the actually the our world consisting of the 3D information, but actually when we take a picture, we receive or we get the 2D projected image. So to understand the scene properly, we have to reconstruct the 3D information from the 2D partial information. So here is the example. So this figure shows the reconstructed indoor image by using the deep neural network. And right bottom images shows the reconstructed output 3D point cloud by using the deep neural network. Computer vision also enables understanding human, for example, identification or the human pose or the 3D shape of the query human, something like that. These kinds of information can be used to understand humans in robot or the surveillance CCTV camera, something like that. And here is an interesting application where machine can detect the human face, even extremely tiny one, as you can see here. Actually, for this kind of the patches, it is really hard to detect even for human, right? But by using the deep neural network, nowadays we can detect such a tiny face as well. Here's another example that segment to each instance, such as the person here and car here. Where's that? Bus here, or the where's that traffic light here, something like that, using the deep neural network as well. Here is another very interesting application. By using the recent deep neural network, we can now generate new realistic images that does not exist. Actually, this image is a fake image. It's not a real image, but looks so realistic comparing to the previous one. So nowadays we can generate the new face or the new object images by using the deep neural network, especially generative adversarial network. Actually, in this course, we won't deal with such a high technique, but in our graduate course, we will talk about such kinds of technique. But in this course, in this deep learning course, we will just develop a small, tiny, actually not small, but simple module. So I will explain to you later. Anyway, so image restoration for colorization is another example. From old gray images, something like this, because the previously we only have the grayscale image because there was no color camera, right? So what you want to do is to reconstruct the color information from this grayscale image with aid of the deep learning. So by using the recent computer vision method, we can solve this problem as well. Um, Another example is here. So computer vision technique can be incorporated with uh, other 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 application. For example, natural language processing. We can build a machine that describe image, as you can see here, as a caption in bottom here, and communicate each other. Machine can communicate each other with an image to describe this image. So by using the deep neural network, nowadays we can build such a conversation module. Here are another example of the image captioning from input image, something like this. If we see the first image, this description describes the input image very precisely with some visualization. We will talk about this one later, but This is another examples of the computer vision application. Okay, so far we talked about what machine learning is, what deep learning is, what is the application of this kind of technique. So, is there any question or the comment so far? Okay, so you can use you can use chatting in our Zoom. Where is that? Yeah, our Zoom platform. So you can freely use that. Anyway, so in this course, we'll talk about the deep learning and computer vision. It mainly consists of the two parts. In part one, we are going to define and um, understand fundamentals of the deep learning and its training technique. And then in part two, we are going to implement the deep learning fundamentals and algorithm and a few computer vision applications. This is the general course information. My office is at Science Library Building here. But mm no, you can come in. Yeah, you can come in. And office hours here the Friday 2 to 4 p.m. But if you let me know before you come, it will be better. Okay. And the lecture will use the live Zoom platform like today. And we are supposed to regularly meet on Monday and Wednesday between 5 to 6:20 p.m. And all the material will be uploaded at the lecture notes tab in Blackboard, right? So you can check the today's lecture note in our Blackboard site. So if you cannot access that, please let me know. And our live Zoom link will be found at the lecture room or Zoom tab. And all lectures will be recorded and uploaded to our YouTube channel. So yes, and if you have any question, you can use the Q&A tab in Blackboard. Okay, so this was the general information of this course. And this is the tentative course schedule. So today is the first week. From next week, we are going to talk about the linear regression, logistic regression, and learning theory, which are fundamentals of the machine learning. Then we will start introduce the deep learning, neural network, and backpropagation. And we will also have the Python tutorial and the linear classification implementation, which is related to our first project, and the convolutional neural network. And then at the second part, we will more focus on the implementation, especially about the computer vision technique. We are going to talk about the CNN architecture and PyTorch tutorial and the CNN architecture implementation, training neural network, visualizing and understanding deep neural network with Star Transfer project and the recurrent neural network and encoder decoder architecture and selected topics in computer vision. And most importantly, there will be a final exam at the end of this course, which might be offline exam, but you will depend on the situation that time. And and there will four kinds of project implementing the deep learning fundamentals and computer vision algorithm. All class assignment will be in Python and use some NumPy and PyTorch library. Um, we are going to have the bit tutorial for the Python and PyTorch coding, but but it might be it might not possible to cover all the technique of the Python and PyTorch library within one semester, right? So I strongly suggest you to take a time to study the basic rules of the Python coding yourself. Okay? So here are four kinds of project here. So first project is the linear classifier and MLP. And second one is the CN architecture, consisting of the VGGNet and ResidualNet. And our third project is about the style transfer to mix the content image and style images, which will be discussed later. And we will also implement the encoder and decoder network that predict the per pixel prediction, something like the depth information or the semantic segment information given input single input data. Okay, so we will implement these kinds of technique within this semester. And here are some self-study material. You can freely access the CS2000, no, CS231 Python NumPy tutorial. And here, or you can benefit from the PyTorch official tutorial site here. Okay. And then in this course, no book is mandatory. Nevertheless, the following books contain the parts relevant to the discourse. Um, Something like the linear algebra and learning from data by the Gilbert Strang, who is the most prominent professor or the expert in the linear algebra field. I'm sure all of you heard about him. And another book is the Deep Learning by Ian Goodfellow. He's one of the nowadays one of the most popular computer vision researcher because he developed the generative adversarial network, just called the GAN, which is one of the most successful algorithm these days. Okay, so I strongly suggest you to read this paper if you have any time. And here are two more books for mathematics of the deep learning and dive into the deep learning. Okay, so these kinds of the three books can be accessed by online using the maybe free, right? So you can easily check this book in your platform. Okay, so okay, so actually, this is the last page of today's lecture. This is the grading policy of this course. You will get the 40% point with the course project, and there will be the four kinds of project, as I mentioned previously. Um, each project has the 5% point for code or the implementation code, and the 5 percentage for the effort. And there's gonna late policy, something like in manner 25% off per a daily or one daily. Okay, and there will be the final exam at the end of this semester. It will be offline exam, but it depends on the circumstance, but it will be announced soon. Okay. And one more thing is that participation. Um, we won't check your attendance every class, but I strongly suggest you to attend this class and ask something you have or discuss something you found in this class. Okay, so I did not decide the specific rule for this class participation, but I strongly suggest you attend every class. So it will be really helpful for you to study about deep learning and the computer vision application or the computer vision field. Okay. So this is the end of today's lecture. Again, I'm really excited about teaching this class and studying deep learning and computer vision with you. I hope you also really enjoy this class and learn something from this class, or learn the basic concepts of the deep learning from this course. Okay, so in the next lecture, in next Monday, we are going to start with the linear regression or supervised learning. Okay, thank you very much. Okay, so if you have any question, please raise your hand. If not, let's finish today's lecture. Okay.